Let's do some coding practice to continue learning about inner joins in this video. Joining our normalized tables back together to get the result set of information that we need is what joins are going to do for us. Let's make the vart our current database by typing in use vart and running that. And let's get a list of all the titles of each artwork. Select title from artwork and run that. What if we also wanted to find out the artist who painted each one and add their name to the result set alongside of their artwork? If we look at everything in the artwork table with select asterisk from artwork and run that, we'll see as we look through these columns, there is no first and last name fields or values. That's because when we designed and normalized this database, we had to separate out those tables, that information. So the only thing we have in this art table that shows who created the artwork is the artist ID as a foreign key here in the last column. Okay, there we go, this last column here. All right, but let's go ahead and if we added this to our select statement up here and we put artist ID, we could see the artist ID of who painted each one of those artworks, but that's not really what we wanted. We wanted their actual names. Also, it's good to keep in mind that users won't know what the artist ID number is for each painting. Primary and foreign keys usually are not seen by the end user, so in order to make a database application user-friendly, if we were going to use it for an application, we want to allow users to search and see data that they understand. The result set here is not really useful to our users because they don't know what artists are represented by those artist ID numbers. What we need is information from two different tables, the first and last name from the artist table and the title from the artwork table. Up until now, we've only queried our database from one table at a time. But in the real world of database querying, you would use joins all the time to get result sets that combine the useful information from multiple tables. Let's get a result set that combines columns from two different tables, the artist and the artwork table. We do this with a new keyword that goes with the from clause. The keyword join is a subclause of from. We can take the same query as before and go ahead and we'll add the first and last name. Oh, that's not what we called it, guys. Sorry. Getting my databases confused. All right, there we go. The first and last name to the select list, field list. And then we're going to add that join keyword as a subclause of from, and then the second table. Okay, we added this second table artist because the first and last name did not go with just the regular artwork table. We had to use this subclause in order to add the other table that first and last name actually belonged to. Right. So when we type the keyword join, it's implying an inner join. We can also, let's type the word inner here, and it would mean the same thing. It's still a join. It's an inner join when you put just the word join. We're going to talk about outer joins in another video. If we try and run it at this point, I'm going to take this off to show that it implies that already. If we run it at this point, we get what is called a cross join, which returns every combination of a row from one table with every row from the other table. And so you can see how many rows we've got here. All right, this is not what we wanted. We wanted only the results of where the tables are actually related, or in other words, where the primary key of the artist table is related to the foreign key of the artwork table. So we have to include a join condition with an on clause. The on clause states how the two tables are related, or which tables we're using to relate those two tables. We know that the artist ID is the primary key of artist, and the artist ID is also the name of the foreign key of artwork. Those are the two keys or columns that relate those two tables together. So we're going to use those with the on clause. And I'm going to bring this down, even though it doesn't really matter, just indent it like that, just in case I got more joins later, it will make a little more sense. And then I can add the on clause that we're talking about here, and we will put artist ID equals artist ID, meaning our artist ID of one table is the condition that relates to the artist ID of the other table. But if we try to run this now, it's going to give us an error down here, and it says artist IDs in the on clause is ambiguous. That's because we have the same exact name for our primary and foreign key names. It's their artist ID. It wants to know which artist ID we're talking about. Now note here, if the primary and foreign key names are different, we wouldn't have gotten this error. But because ours are spelled exactly the same way, we have to say which table those columns or keys are coming from. We use what's called a table qualifier, and all that means is we precede the column name with the name of the table it comes from and a period or a dot after it. So we're going to go ahead and say, okay, this artist ID comes from artwork, the artwork table, and this artist ID comes from the artist table. And it doesn't really matter the order here. Now, when we run it, we will finally get the results that we expected. Vincent van Gogh's first and last name is repeated for each of the artworks that he's created. He has 3 paintings that relate in the artwork table and that are listed here. He has the artist ID of 1 in the artist table. Remember, let's go ahead and show that. Select asterisk from artist, run that. We'll see that he has the artist ID of 1 here. Okay, so when we ran that, and let me just show his artwork. So if you run this one and look over here, these first 3 have the foreign key of 1. So that is what's getting joined with this on. It says where those 2 numbers are the same. So that's why when we run this, we're getting the connection here and getting it joined properly. Okay, there is a using clause that can be used in place of the on clause, and I'm going to show it here, but it wasn't in your preparation material for a reason, and I'll share that here in a minute. But you could replace the on with using, and then inside of parens, the name of the primary and foreign key that relate those 2 tables together, and we'll get the exact same results. But your primary and foreign key would have to be the same exact name, which is true of these tables. But I want to make you aware of it because you could see it in code. But remember, the using clause isn't universal for all RDBMSs, or relational database management systems. And there are some limitations with using. So this course won't be really teaching this clause, but I did want to show it to you. And it is a little less typing if you have a database that uses the same name for primary and foreign keys. But let's switch back to the on clause. That's what we'll be using. Whoops, I'm not getting it back. Hold on. And let's go ahead and add a filter here. We're going to say where the last name is equal to Vinci. And we'll just get Da Vinci's on there. Even if we only see the title and we take off the first and last name here from the select statement, we would still need a join because our where clause is using a column from a different table. So it's not just the select statement that you'll need to look at to see how many tables you're going to be using in the join, but other clauses as well. Because our select only has a column from one table, but we'll still need the join because our where has uses a different table right here. So let's go ahead and look at the bike database. So I'm going to make some room here, and we're going to say use bike and run that one. And now our bike is our current database. And let's look at the relationship between the product and the category table. Select asterisk from category. And we'll run that, and we see we have 7 different categories with category ID as the primary key. And this is a type of a lookup table. Now if we do select asterisk from product, we'll see that the category ID is used as a foreign key to show the category each bike belongs to. Let's get a result set with the product name and the category name and the list price. We're going to say select the product name, the category name, and list price from product. Now, not all of these columns come from product. We need to also include that include the table category in order to get the category name. So we say join category after the from statement. How are those two tables related? We use the on clause. They're related with the products table category ID and the category table's category ID. So the foreign key in product and the primary key of category ID is how those two tables are related. Now if we run this one, see that we can get all of that information together. If we want to add the brand name to this result set as well, this is going to involve 3 tables. We'll have to add the brand name, the brand table into our join as well. Again, this is a lookup type of table with 9 different brands that you can see here. Select asterisk from brand, and you'll see it's got 9 different brands. You can also see this on the ERD right here. The product is related to categories. Here, each brand can belong to many different categories, and each brand can belong to many different products. Each category can belong to many different products. So we can see that relationship as well. So in order to get the brand name, we're also going to have to join that table on there. All right, so we are going to come back up here, and we're just going to edit the one we already have, and we're going to say join again a 3rd table called brand, and we have to always have the on clause with every join, and this one will be joined by the primary and foreign key of the category or the product and the brand table. So we're going to say the product brand ID equals the brand ID. Now if you're wondering how I just know these, you can always come over here and look at those tables. First of all, you could look at the ERD. You could say, okay, I'm looking at these two tables, joining these two together. And you can actually physically look down the list here and see which two keys are related, the primary brand ID and the foreign brand ID. And that's how I knew when I was joining the product table to the brand table that that would be on either side of my equal sign, the brand ID. Same thing with the category. I looked between these two tables and said, okay, category ID is the key that relates those two tables together, and that's why I used that one. So that's how I'm understanding which is going to go after the table qualifiers between the equal sign. These will always be the same primary and foreign key that relate on there. Okay, let's run it. And now we see not only the product name, we do need to put the brand name up here in the select statement, or it won't show. It is joining them, but it's not showing the brand name. Okay, so now we have the product name, category name, brand name, and list price from 3 different tables. We could also add a filter at this point if we wanted, and say where the category name is only children's bike equals to children bike. Better spell it just how they have it. Children bicycles. Okay, so now we're limiting it to just the children's bicycles. You can also use aliases for your table to cut down on how many times you need to type out the tables in your join. So I could come up here and I could say, let's give an alias of P for the product table, and let's give an alias of C for category table, and an alias of B for the brand table. Now at this point, once you include the table aliases, you do need to use them everywhere you refer to that table from that time on. So you would have to actually use the same table aliases in your on clauses and anywhere else that you might need to qualify a similar, if the two tables have similar column names in the select or the where, you would also need to put a table qualifier in front of them. So if both tables had a list price for some reason, you would have to put a certain table in front of each one of those. All right. But remember, if you use a column in the where or select that could be from 2 different tables, you have to use those qualifiers there. And remember, the from in our order of execution runs before select. And that's why you would have to use the alias up here as well, even though it's below in the order of our coding. And if you leave any of those off, you're going to get ambiguous errors. All right, let's run it and make sure we get what we expected, and it runs the same way. Okay, I want you to try one on your own. We want to get a list of the staff, the first and last name, and we're going to be using the same bike table, but this time the staff table. The first and last name from the staff table, and we want to get just the staff from the Roulette bike store. So the name of the bike store is in a different table, and we're going to be filtering it by only the Roulette bike store. So pause the video and see if you can get this one on your own. So the first and last name of the staff from the Roulette bike store. You can't use store ID number 3, but the actual name of the store in code. Okay, go ahead and try it. Okay, here's what I came up with. The 2 columns that relate the 2 tables of our staff and store is the store ID column. You could have also used the like keyword in the where if you didn't know exactly how to spell, or if it was Roulette shop or Roulette bike shop, or if there was 2 T's, maybe put an asterisk after there. So you could have used the asterisk there too. You could also have brought the join down on its own line. It would have ran exactly the same. But if I did use store ID in the where clause for some reason, so say we came up with wanting to do it this way. And we knew roulette was store number 3. Now again, your user's not going to know that. But if we did use this and try to run it, we're going to get an error. Store ID in the where clause is ambiguous. That's because it's not sure which table the store ID is referring to. In our case, it doesn't really matter, so I can put whatever table qualifier I want here. I could put store or staff. Yeah, doesn't matter. And it will still show which one. But I did have to qualify it even here because store ID was in 2 different ones. If we also wanted to show it up here, it's going to give us an error because we have to qualify it there as well. And you can choose whichever one you want here, and then it should run. Let's look at joining more than two tables. Let's join 3 together, and this time we're going to be using the art database and try a multiple table example there. We want to show all the artwork titles that use the keyword water. So I'm going to type use vart, so we're on the vart database. And we're going to be selecting, we want to give all the art, so we're going to be wanting to see the title from the artwork table. And then we're going to be using a filter that's going to be using a keyword. So we're going to have to join these together. Now, if you look at the artwork table and the keyword table, they do not have a primary and foreign key that is similar between just these 2 tables. We have a linking table in between them. The linking table has a similar key for artwork and artwork keyword, and it also has a similar keyword or a connection relationship between keyword ID and keyword ID. So we can't just jump right from artwork join keyword, because we wouldn't have an on clause that would be able to give us a related value. So we have to go through artwork keyword first. So we really have to join all 3 of these tables, even though we only need information from artwork and keyword. So we're going to go ahead and join artwork, keyword, the linking table. Those 2 are related by the artwork ID. And since they're the exact same name, we do need to qualify them by putting the table name in front of each one, the artwork ID from one table and the artwork ID from the other table. One's a primary key, one's a foreign key, or composite. All right. And then we also, in order to get the keyword, we need to join that keyword table, and we'll get the connection between the linking table artwork keyword and keyword on our on clause. Artwork keywords keyword ID equals the keyword ID. Now here's where our filter, we wanted all the titles that use the keyword water, so we need to put where keyword equals water. And then we get the 3 that have the keyword associated with water to show up. So again, in the select, we want a column from the artwork table, and in the where, we referred to a column from the keyword table. That's 2 tables. So why did we need to join 3 tables? Because when we looked at the ERD, the artwork table didn't connect or relate directly with the keyword. There was a linking table between them. So there wasn't going to be any column that would be the same for the artwork and keyword. We'd have to join everything together that connects those tables. So the linking table of the artwork keyword had to be added as well. Again, you can use table aliases here, and this one would have been nice for this one, and would have cut down on all the typing that we had. We could have put A for artwork, we could have put AK for artwork keyword, and we could put K for keyword. Then we only would have had to put A here, a K here, a K here again, and K. Okay, and let's just make sure, didn't make any typos. Yep, runs the same. All right, let's try an inner join on multiple tables. The inner joins go, or before we get to the outer join video that we're going to show, let's try the employee ERD that we're going to work with, and you'll see that this week. So I'm going to say use employees and run that. And let's go ahead and look at the ERD. Paused it and got the employee model up here for you. And here we can see that we've got a number of different tables. We have the salaries, employees, department, employees, departments, and department manager. So we're going to be using 3 tables. We want to find the name of an employee and his salary and what department he works for. So this is in 3 different tables: salary, employees, and departments. Remember, we can't jump straight from employees to departments. We do have to go through department employee here. So pause the video and see if you can figure out how to get the name of the employee, the department he's in, and his salary. Okay, let's go through the process of how I did it. So you've got to join all of those tables together, and notice that to join between the employees and departments, remember there was no foreign and primary key that we could link them in the on statement. So we'll have to also join them with the department employee table as well. So this is really going to join 4 tables. So I would always just start at one end or the other, maybe salaries or departments, doesn't matter which order, and I would just kind of go down the line through all the relationships here. So let's just say I'm going to start at departments. So let's go ahead and get the select of what we want to have show here. Remember, we wanted to have the first name, maybe the last name, and the department name, and the salary. And we're getting that from, and I'm just going to go ahead and start maybe up here, and you could have started at salaries, but I'll start with departments, and I can quickly look and see these are probably going to be the first 2 tables. They both have department number in common. So I'm going to say from departments, and I'm going to give it an alias right off the bat this time. Oops. And then join department employee, and they're related with on by the department number. I'm going to, let's give this one a DE alias. And we'll go ahead and say they're related by the employee number. Sorry guys, I was down a line. The 2 that were the same between departments and this one were department number, not employee number. So I need to say department number equals department employee tables department number. Okay, then we go on to the next connections. It's going to be between department employee and employees. And so we'll say join the employees table on, and let's give employees an alias of E. E dot employee number equals DE dot employee number. Now, it doesn't matter if I put DE here first and E here second, as long as it relates those last two tables that I've got there. Okay. Then the last one is us joining then employees with salaries. So we can get his salary amount. So we're going to join the salaries table. We'll give it an alias of S on the employees table, employee number, and the salaries employee number. Now again, I got the EMP number because these two columns, or these two tables, have those two fields in common for the primary and foreign key. All right, when we run that, we will get everybody's salaries. Mary's got many different salaries because she's gotten raises over time. But what if I then was going to filter this by the from date? So maybe we just only want from a certain date. So we're going to have from date up here, which is actually, maybe we're looking at this from date right here in the salary table. Okay, and I want to say where, well, let's just do it that way. Let's just throw in the from date. I get an error that says field list, from date in the field list is ambiguous. Note on the diagram, we have a from date as well in the department employee table. So because they're all joined together and we go ahead and use that in the select, it has no idea if we mean this table or this table because there's a from underscore date in each of those tables. We do want the salaries one, so we are going to qualify it with, and I can't say salaries, that won't work. It will still give me an error because we have already gave it a table alias of S. So I've got to actually use S up here. And then we can go ahead and get that from date to show up. And the same thing, if I have it in a where clause, and I say where the from date is greater than maybe the year 2000, December 31st, I will get another error because it doesn't know what from date again. So again, I've got to put the table alias there, and it should go ahead and run it, and now we only see above 2000 showing up. Okay, so let's keep practicing because this is something you really want to get down. Let's use a database where the primary key name is different from the foreign key name. And just because we've been using databases where the primary and foreign key are exactly the same name mostly, it doesn't mean you're going to run into databases where those keys are not different names. So they still will use the same values to relate the table together, but the actual names of the key headings are different. Let's look at the world database. Here's the world ERD. And it does have a primary key for country that's called code. The foreign key value that relates to the values here in code is country code. So there's two different names there, but it's the same values that are relating those two tables together. So we can see that if we come here and we say select everything from country, in fact, let's make sure we're using world. And it's now the current database. And if I select everything, we can see the code here. It's not even an integer, it's 3 letters that represent that country uniquely. Now, if we look at everything in the, copy that, in the city, so that was the one that had the foreign key, city, and it's called country code. we'll see it's the exact same code here, but now it's being used as a foreign key and it can repeat because there is a one-to-many relationship there. So it's the exact same value, but we do have it as two different names here, and that's kind of different from the other databases that we've been using so far, but you will see this out there in industry, and I wanted you to be aware that always your primary and foreign key don't have to have exactly the same name, even though that's kind of how we've been using it in our class. So this is what I wanted to go over. So if we did we said select the name, name from city. We can see all the different names of the cities, and there's like over 4,000. It's a very big database. Okay, so now if we wanted to get not only the name of the city, but we also wanted the name of the country of where it came from. So kind of like the artists with their artwork, we want to get the countries with all their cities to show up. So we can come back here and we can put, okay, we also want the country name. Now notice, again, we've got a name of the country and a name of the city with the exact same column name. So we are going to have to table qualify that. We can see that right now. So let's give them some table aliases, and we'll go ahead and join the country table. And this is what's cool. This is really why I wanted to show you this, because now on the on clause, we do not, let's give this a country CO. We do not have to use a table qualifier here at all, because we can just say country code equals code. And again, I could have put country code first and code second, but I don't have to qualify that name anymore. But you will see we will have to qualify these up here because it will not know which name we're talking about. Okay, so now if we run that, we can get all of the countries and all the cities that belong to them. And I probably want to reverse this just so it makes a little more sense to me. Okay, so the countries are here. So Afghanistan had, 4 different countries or cities in Afghanistan, the country represented here. Angolian has quite a few and different things like that. So that is the idea there. Sometimes you have a primary and foreign key with different names, and at that point you would not have to table qualify those. Okay. All right, one more practice. I know this is getting really long, but I want to make sure you guys understand that. Let's say we want to use the bike again. So we're going to be going back to the bike database. Use bike. And we want to go ahead and just pause here because I'd love to see you try this one on your own. We want to look up all the products that Mr. Baldwin has ordered. We want his last name and all the product names and order dates from this. Let me just quickly show you the bicycle ERD. Okay, so we want the product name and the order date right here. And we're going to be just getting the last name of Baldwin. So all the products that Mr. Baldwin has ordered. So go ahead and try that yourself. Okay, so here's what I came up with. We needed the product name from the product table. We needed the customer table to filter with, and we needed the order date from the cust order table. So we joined customer, cust order, and then we had to use customer order item to get to the product table. And this should then give us the results that we would need. These are the bikes that Mr. Baldwin ordered. So these have all been inner joins. getting just the data that has a relationship between the joined tables, meaning there was a primary key that had a matching related foreign key of the other table. Inner joins are the most common type of join. The next video we're going to be looking at outer joins.